చూడు ఈరోజు ఫాస్టింగ్ ప్రేయర్ అంటారు.
అవును 10 నుంచి ఫాస్టింగ్. 10 నుంచి.
ఇప్పుడు అన్నం తింటావా? అన్నం తింటాలేందిరా అసలు నాకు అర్థం కాలేదు.
కూర తింటా అయితే కూర పెట్టు.
తలస్నానం చేయరా?
హల్లెలూయా. మట్టాయి. హలో హలో హలో. కొంచెం పెట్టుకొని
నీకు నేను చెప్పాలా నువ్వు నాకు చెప్పాలా?
తెలియదు మమ్మీ,
ఆ?
తెలుసుకొని చెప్తాను నీకు.
ఇడ్లీ చేస్తాను.
పూరి కూడా చేయి.
ఏంది ఇంకొక థ్యాంక్స్ పూరి చేయటం పెద్ద పని అనుకుంటున్నావా ఏంది? పిండుకుంటావా నూనె గారెను పిండుకున్నట్టు? ఏమో మళ్ళీ కడుపు నిండదేమో నాకు ఎందుకు.
ఇడ్లీ చేయి.
మన రేపొద్దున కూడా ఇడ్లీ అవుతుంది కదా.
అందుకే చపాతి
చేసుకోలేమమ్మా.
పని చేస్తే పెరిగి నైట్ చపాతి తింటే పెరిగిగా ఇట్లా ఉంటుంది. ఆకలి అయితే ఏం చేస్తావు రాత్రిపూట? ప్రేయర్లో ఉంటే అవ్వదు.
4 రాకుంటావు
డైరెక్ట్గా అక్కడే స్నానం, మార్నింగ్ అక్కడే అటెండ్.
చెప్పు ఏంటి అన్నం పెట్టమంటావా ఏంటి? చెప్పు త్వరగా. డిసైడ్ అయిన ఒకటి అయిపోవాలి.
చెప్పు త్వరగా. నీకేమొద్దా? నువ్వేం తింటావా? సరే అమ్మ అన్నం వండే ఎందుకు ఇవ్వాలా? ఇంకా డిస్టర్బ్ చేయకు, డోర్ వేసేయండి. మీ ఇష్టం. స్టార్ట్ అయింది జనాలు యాడ్ అవుతున్నారు. బయట కూర్చొని డిస్టర్బ్ చేస్తూ ఉంటుంది మరి. జాయిన్ అయ్యా నేను అప్పుడే కనపడతాయి. లేకపోతే ఎందుకు కనపడతాను? ఇద్దరు మాట్లాడా.
హలో చెప్పు. 7 అయింది.
హలో ఉన్నారా? ఏంటి
వెళ్ళు మరి.
మరి పప్పు ఉంది కదా చేసేదా? చపాతి 9 చేస్తా. సరిపోయింది. ఏమి వాడు చపాతి అని కోరుకున్నాడు కదా. ఏమా
ఏదో
కాదు చెప్పాలి.
ఏదో
పప్పు ఉందని అన్నం తింటా.
ఫాస్టింగ్ ఉందా? ఎందుకు గోళ?
ఏ గోళ లేదు అసలు. ఓ చెప్పు 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 త్వరగా చెప్పాలి కంటే టైం ఉంది.
రైస్ పెట్టాను.
నువ్వు కూడా రైసే.
తీసే ఉంచిన
వద్దే వేసే. ఒక గంట డిస్టర్బ్ చేయొద్దని చెప్పు. చదువు వర్క్ ఉందని. చెప్పవా? ఇది అదేం తీసుకున్నారు?
క్లాస్ చెప్పు.
తీసుకో పర్లేదు.
వాళ్ళందరూ వెయిట్ చేస్తున్నారు కదా, ఉన్న వాళ్ళు కూడా పోతారు క్లాస్కి.
అమ్మా.
చెప్పు దగ్గర
సరే
చేయండి.
Yeah, good evening everyone. So welcome to sixth section on metrology. So today let us discuss some part of discrete measurements and also discuss some numericals related to this topic. So in the last class there was some discussion on this question. So which of the following is true statement? So there were two correct answers in this. So one is the no, that's option C, the go gauge controls the lower limit of the hole, as well as option B, the no go gauge controls the lower limit of the shaft. So this is also the correct option, but the key given is the option C. So one possible explanation for this would be this control statement. Instead of controls, if it is corresponds to the lower limit, it would be a like a correct answer. Since the go gauge is like the full form, it enters the every every component, so it ensures that the lower limit is controlled. So that would be the one possible explanation, and I would welcome if there is any explanation from your side. since so that only the option C is given, and in some papers this Go is missing. But I have checked the actual paper from the website, IIT Kanpur website, in which this question was framed. But in that question, this statement is true. The options are as it is. It is clear that no go gauge controls the lower limit of the shaft. So that would be one possible explanation. If you get any better explanation, you can we can discuss in the future classes. Okay. So let us start the today's session.
Which option we should go?
I will go with the you already have one question like that. Okay, so better go with the go gauge only. Since there is one weak explanation, I can say, that is the go gauge is in full form. It enters every component, so it ensures, so it controls the lower limit. Whereas no go gauge, it will not enter, and so it corresponds to that limit. That could be an explanation, but I am not 100% sure. So if this question appears, you can go for the go gauge only if the same question appears. I don't think they will use this tricky.
Okay.
Okay. So in the last class, I have just discussed some of the concept on the screw thread. Let us discuss in detail all these nomenclature of the screw thread. So as you can see, I have noted with the numbers. Like first one is the major diameter, which is measured using flat-ended micrometer. The second one is the minor diameter, which could be measured with the thread micrometer, pointed anvil micrometer, toolmaker microscope. Okay. Then the third will be the thread angle, that is 2 theta, which is measured using optical projectors. Okay. Then come the pitch, which is measured by the pitch gauge. Then the fifth one is the pitch circle diameter, or the effective diameter, which will be measured using 2 or 3 wire method. So this wire method, if the pitch is too large, then we'll go for the 3 wire. If it is very less pitch, then we go for the 2 wire method. Then we also discussed this measurement of inner dimensions, like inner thread, which is measured using this wax, which was filled up to 40% volume. Then pitch, angle, everything is measured the same as you measure in this, or else you can take 0.4% approximate value of all these values, major or minor. Then this was the little bit of nomenclature. Let us so there is one derivation we discussed in the last class, that is the best size wire. Let us discuss the same here also. Before that, so we have this pitch circle diameter or effective diameter, this one derivation. You can directly remember the formula. I will just show you how it was derived. So for that, we have initially we have to consider a pitch. So I will take 2 flanks. Okay. So this was the wire, and I'm not sure whether it is the best size wire or not. So I'm considering it is not the best wire size, and I'm doing the derivation. Later I will consider. We'll see what happens if it is the best wire size. So we have the pitch. is the thing that we are going to measure, that is the pitch circle diameter. Okay, then this angle is theta. Okay, so these are the notations. Then this is the radius of that wire that I am keeping. So I am denoting it as by dw by 2. That is the diameter of wire by 2. That's the radius. So now we have to reserve this length. So this length x. I will tell you how this x is useful later. So this x, I can write this x as OC minus OB. Okay, this is O, this is C, which is, so here OC is nothing but the radius. Okay, let us keep it aside. So now this OB, I can write this OB as OD minus BD. So this length OB. This is D. Okay, OD minus BD. So now we consider these triangles. So I will consider two triangles in this. One is triangle OAD, that is OAD, and the other triangle will be ABD. So this, and this. So initially first triangle, that is triangle OAD.
Sir, can you again tell how the thread angle is measured?
This thread angle.
Yes, sir.
So here I have drawn. It could be like this. Okay. This is theta. For convenience, I just kept the theta with the curved surface.
Sir, how it is measured practically?
Practically, so yeah, you take the screw. So you just take the screw and you just project it. Okay, just assume this as a thread. You just keep a flat surface and you just project it. Keep a light on the top and you will get the shadow of that screw, right? With that, if you can measure this thread angle, that would be the angle that we require. Using projection method, we measure it.
Okay, sir.
Okay. Or else you can I showed you in vertical position. You can do that in horizontal also. Keep a screw thread like this. Keep a light source here. Keep a screen here. You will get it. Take a picture of it and you can measure using. There are so many tools available.
Okay.
Okay. Then this it. Okay. Now coming to this derivation. So we considering triangle OAD, that is OAD. sin theta is equal to OA by OD. So from this we find the OD. So if you see, OA is nothing but the radius of the wire, okay. So now similarly we consider the other triangle that I am telling, that is triangle ABD. So if we take tan theta, okay. So from this I will take this. So why I'm doing all this is I need to find this x value. So for that I need all this, nothing but P of 4 cot theta. Okay, AB is nothing but P of 4 cot theta. So I have the two values, that is OD and BD. So if you see OB, that is nothing but OD minus BD, that is d double by 2 cosecant theta cot theta. So I got the OB value. From this OB value, if you see, OB is the unknown here. From this I will find this x value. So after rearranging the terms, so the x, okay, this is the final equation, that x value. So this you have to remember, or you can do the small derivation if you remember, because this x value we should know to find this pitch circle diameter. So now comes the final part of finding why we need this x value. So for that I will take the screw thread.
Sir, please, can we go to last expression once?
Yeah, I will. Just a second. This is the expression. I will rewrite this again. Okay. So now if you see this x value, so this x value is the distance between this line of pitch circle and the lower contact of this the wire that we are using. So now if you see this is the x value, this is the x value, okay, and along with this I need two more readings for this. That is the reading from the top, that is this value, and I also need the bottom value, that is so this value. Now finally this t value is nothing but, okay, the final distance m minus the wire diameters. So now so I have the t value now. Now the pitch circle diameter would be this t plus 2x, okay, this x and this x. If I add it to this t value, it will be 2. This is the final expression for the pitch circle diameter, that is pitch circle diameter is equal to t plus 2x, that is m minus 2 dw plus 2x, that is m minus 2 dw plus 2 into this final equation, that is W by 2. Okay. So this is the expression for this pitch circle diameter. So if there is any, by chance, if there is any question, you don't have to remember this big formula. There will be some clues in the question itself, or else they will give the final equation. So no need to remember. I just showed you because there is one derivation for finding pitch circle diameter. Now, since suppose this wire size is the best wire size, so in that case, so in this triangle, I have considered suppose if I take angle OAB instead of the other OAD or other circuit, other one, so what happens is that there will be, the error would be minimized. Triangle OAB. I have not considered this OAB triangle anywhere. You see, I have considered triangle OAD and triangle ABD because I'm not sure the wire size I'm using is the best size. Beforehand also I can know, suppose you know the formula of best wire size, that is P by 2 sec theta. Okay, if they have given me the pitch value and theta value, I can find the best wire size. If I don't have these two values, then I am clueless whether this best wire size is it best wire or not. So in that case, I have to do this all the derivations. Otherwise, I can directly take this triangle. I can go forward with it. Okay, just go back once and just see what if I use instead of using these two triangles, if I use this triangle. So that would completely this much derivation would be completely in few steps you will get this x value. Okay. So if anyone is wondering, so if I take if this OB value, for finding OB I have done all these things, but if this is the best wire size, I can directly find this OB value with one line, so that that would minimize all this derivation. So let us do one numerical, then we can proceed with the other part. Okay. కరెంట్ పోయిందా? ఆపేలా రన్ అవుతుంది. కరెంట్ పోయిందా మరి ఎలా? ఆ సౌండ్ ఏంది అలా అవుతుంది? ఎలా ఇప్పుడు
టెక్నికల్ ప్రాబ్లమ్ టుడే క్లాసెస్
మళ్ళీ తీసుకెళ్ళి తీసుకుంటాను. మా సౌండ్ బాగా వస్తుంది మా అక్కడ
బయటకు వచ్చింది
కదా
వైఫై రా
సౌండ్ వస్తుంది బాగా, ఫ్యాన్ సౌండ్ బాగా. వైఫై రాదా? ఫ్యాన్ పెద్దగా వస్తుంది. ఆ రూమ్లో కూడా వస్తుంది సౌండ్.
ఇక్కడ కూర్చోరా బయట ఈ తలుపు
తలుపు
ఇక్కడ రావట్లే బయట. ఇది తీసుకున్నావా?
వైఫై రాదా?
రాదు.
కొంచెం ఇవ్వను.
ఉంటాయి రైట్గా ఉంటాయి
ఎండిపోతుంది.
బాయ్ ఏం చేస్తున్నావు అయినా ఫోన్ తీసురా చాలు పెడతా పెడతా
తిమ్మిడి కూర్చో. కూర్చో.
రాట్లా Yeah, sorry, there was some power issues. So as we are discussing, I will give a small numerical on this physical diameter, then we move forward with the things. Okay, we have pitch as well as the wire diameter, and we have a standard cylindrical standard diameter of 30.5, and we have two readings, over the standard and over the screw thread. With these values we need to find the effective diameter. So if you are wondering what is the standard, so initially they measure on the standard specimen, that is which is nothing but 30.5 with a and then they also measure with this on the screw thread. Then they find the error on the micrometer. When they then they will take that error forward in order to find this final pin circle diameter. Okay. So the formula, I will write the formula for this pin circle diameter.
Sir,
Yeah.
so again, this final part, finding the
Okay.
actual
So final part means in this question.
While we derive,
Haha.
after we got the expression, we took the help of T and yes, this part.
So we will so these values we can measure the M and T values. From that we can find this T value. We already have X value, so that this is the pitch circle diameter. T plus 2 times the X value.
Yes.
Okay. Sorry, I didn't mention. It's a metric thread.
So can you explain this terms, effective diameter, reading over standard, reading over thread?
Okay. Yeah, I will explain in a minute.
Sir, from the metric thread, the thread angle is 60 degree, sorry, 130 degree.
It is total. Thread angle is 60 degrees.
Okay.
So these two terms, standard and thread. So basically we do this. We measure the standard values of this micrometer, that whatever we are using, in order to find the error in micrometer. So initially we measure so they have given a standard 30.5 mm. Okay, and we also have this diameter of 2. then we will get the actual value, which is true value, and the reading is standard is 13.37. So from this we get the error in that micrometer. So that error we have to take forward in measuring this thread, this actual effective diameter. Let me explain here. So these are the two anvils. So we have these are the wires, and we have a standard cylindrical specimen. So we have this value given in the question, that is 13.3768. Okay, as well we have this value as well. This is the reading. This cylindrical specimen diameter is 30.5, and this wire diameter
Sir, how
is.
it can happen, sir? Why was it 30.5 to chota hai?
That's what I wrote here, reading. So this may not be the true value, so that you will get the error. Okay, I'll see. So the actual error in the micrometer will be
So this is standard diameter, sir.
yes. So this is the error. So actual reading should be this 34.5 in the micrometer, but it is showing you 13.37. So the error is 21.1232. Okay. So that it is showing less value. So you have to add this 21.1232 in every measurement for whatever you do after this. So similarly, we have performed the similar thing on this thread as well. Okay, this is two thread.
Which means first case is just a simple wire.
Yes. It's a simple wire with a standard specimen here. Here we have actual thread. So this reading, it is giving 12.2428. Okay. So for this, but this is the m value. If you remember in the derivation, this is the m value. But for this m value, you have to add this error. Then you will get the actual m value. Okay.
So
Actual.
this error is fixed for that measurement always or changes?
It changes actually. We have to measure every time. After some amount of time, we have to measure. Okay,
Okay.
This is the actual m value.
Sir, is the final answer 13.47?
Yes, correct.
So, like just we are adding the 21.1232 to this one.
Correct. Yes.
Yes. So, but how to what the difference?
Yeah. It was there in question. So that's fine.
Sir, can you please show the question again?
Okay. Any doubts? Once you get this m value, you just use this formula to get the t value. You can keep the t value here. You have every values. You can easily get t circle diameter if you don't do any this calculation mistakes. So let us move then. So this was the question related to the last class.
Sir, is it 27 degree per minute?
You try. You take some. So this nothing was mentioned in the question. So you try.
57.78.
Yeah, correct.
Yes, sir.
So the actual convention we used to follow this for minutes and this for the seconds. But in this question they have given 227 with a hyphen and 32 hyphen. So this is 27 degrees 32 minutes. Are you getting this value?
Yes, sir.
Okay then. You can solve this.
Sir, what am I asking first question, sir?
It is 57.783.
No, sir, before this.
Okay, the last one
Yes.
is 30.3970.
Okay, sir.
Okay. Yeah. Okay.
Sir, here the three-wire measurements like one for major diameter and
Can you repeat once?
actually this three-wire measurements we are using three wires for distinct measurements like minor diameter, major diameter.
Yes, yes, yes.
Yes, sir. So those three are minor diameter, major diameter, and effective
It's
diameter.
correct.
Okay.
Third diameter, which one?
That is pitch circle diameter. Major, minor, and pitch circle. Everyone is getting the same value, 1.154? Okay. So if you use this theta correctly, then you will get the answer.
The best one diameter does not affect on the two-wire method or three-wire method.
Yes, yes. There is no effect. Okay then. So this is related to this interferometry, but you can give a try. If not, we can discuss. Yes, correct. So there are two formulas. This is a very simple setup. So we have a two, as we mentioned, two optical flat plates of glass are kept at an angle of small angle theta as shown in figure. Monochromatic light is incident vertically. So when you do that, you will get the fringes. So the spacing is 1 mm when you use 450 nanometer wavelength. So suppose if the spacing is 1.5, what is the wavelength used? So if the spacing is 1 mm for 450 nanometers, for 1.5, how much? Even without this knowledge of interferometry, you can directly do this. But we have a normal formula, that is this theta, which is small. So I am representing with delta theta is n lambda by 2l, where this n is the number of the fringes, wavelength, and the spacing. And this is the formula you need to remember. And we have when this theta increases, as you increase this theta.
Sir, what is delta here?
This angle. Since it is very small, he mentioned, so I use delta theta. Okay.
No, sir.
The spacing between the fringes.
Yes, sir.
Okay. So when this theta is increasing, this wavelength, the path. So when the theta is less, so this is the path it travels, the light. Suppose if this theta is more, it has to travel more. So the path difference is multiplied by this wavelength, lambda by 2, by a factor of lambda by 2. So we will get more number of fringes. Which is nothing but this width will decrease. Okay. So we have yeah.
W means L.
Yes. So that's spacing. So if number of fringes are increasing, the width of the spacing will decrease. Similarly, when this factor, since the width is decreasing, and this when this is increasing this wavelength, the path it travels, so this will be constant always. This lambda by 2, the ratio of lambda by 2 will be constant. So this was one observation, you can say, and this was the one formula you need to remember in interferometry. Then we have one more example. I think not example, one setup. So when you use this optical flat as a comparator. So comparator, it's not a directly will not direct measurement device. It's a comparison with the standard one. So now if you use this optical flat as a comparator, we'll write the formula first to find the height difference. We have this formula. Sorry. I will explain what are these terms. Okay, when you use this optical flat as comparator, so I'm just writing the formula first.
सर आज की क्लास बड़ी स्लोली चल रही है।
Sorry.
आज की क्लास में थोड़ा कुछ ज़्यादा ही स्लो चल रही है।
Okay. It's fine. So let me complete this one. Then we'll see. So there are two methods. One is direct flat when you are using. The other one is when you use it as a comparator. Okay. There is one small fundamental in this to distinguish this value. So the main thing lies in identifying this G value. So we have a two. Okay, and this length is L. This length is G. This length is delta H. Okay. Now the rest principle of will be remaining the same. So we will incident this monochromatic light source, and it will travel a distance similar path. And we obtain this formula. The delta H is n lambda by 2. I'm not explaining every part. I'm just explaining the main concept of the formula because it is not that much important for this gate. So now if you see this delta H, which is n lambda by 2, which is G by L, you know every term. So this n lambda is the wavelength that we are using. This G is the distance between these lengths. These two are identical of length L. Okay. You need to remember this formula if at all there is a question.
So these are just objects in Numerical blocks.
Sorry?
Are these just objects or they are glass?
They are blocks, you can say. Okay.
Since when they use it as a comparator.
Yes. When you want to find this delta H using this optical flat, you are not directly finding this value, you are finding using these formulas. So all this is not necessary for this gate exam. So the main thing lies in identifying this setup. So in the question he might not mention this G value sometimes. He might say they are very close. For example, so we have the okay, I'm directly giving you the values. Okay, this was the question actually. So we have these values L1, L2, W, and the lambda value. So we need to find this delta H, the height difference. We don't have the G value here. Okay. So the actual how these L1 L2 are measured is, this is L1, this is L2. I think I can come with the question. Actually, I don't have the question right now. Okay, no need to do this sum. I will explain what the concept is. So basically, this is the setup that they can use. So there are so many models. Now they can directly give the values of this L value and Z value, and they can ask you the height difference delta H. So the delta H you can find using this formula. The other thing is these models, instead of keeping apart this delta G, this G value, they can keep side by side. Okay, and they can the rest will be same. In that thing there is no G value at all here. Okay, in that case you no need to use this this term. You can directly go forward with the delta H.
Sir, I want to propose that n मतलब G by L की बजाय G plus L by L होता तो अच्छा रहता है.
Instead of G by L?
Instead of G by L, G plus L whole upon L.
Okay.
Because वो G थीटा मतलब G plus L थीटा वाला साइन मतलब उसको कोई फॉलो कर रहा है. L lambda by 2L तो थीटा है सर.
Correct.
So delta H.
Okay.
And that length is G plus L.
Yes. Yeah. Correct. Yeah. Thanks.
Sir, I was asking मतलब ये सही है या फिर नहीं?
So basically this G value we measure the first and the second surface at same point. Sorry.
Including the L also.
Yes, correct. Yeah. I missed that, so that's why this chaos is coming. So this G is nothing but the first and the second point, the distance.
Oh, now it is fine.
Yeah. So that's how this G comes. Okay. So now if you see as I'm explaining earlier, so this is itself is the G value, which is equal to L. So in that case this whole term will disappear. Okay, that's what I'm earlier explaining. So these are the two models they might ask you. Okay. So in this lecture I just want to cover this complete part of screw thread measurements and a little bit of interferometry. I'm not much focusing on this part because it's not that important to get. And I reserved this surface measurement for the next class because it was a little bit important for us. So I will discuss some part of theory as well as some part of numericals on the surface measurements. Okay.
Awesome.
Yeah.
So actually we received the formula for a pixel diameter. It's a T plus 2x.
Yes.
From there, how did we derive this plus plus?
No. They are completely different.
Okay. So
I will show you.
The derivation for it is not.
Yeah, the derivation we have discussed in the last class itself. So this is the sorry. So this is the best first size. DW is the best first size. Here I don't know the value of DW here. So if I take this triangle OAB, I know this AB value, and I also know the theta value. Okay, from that I can find this best first size.
Yes, so basically this concept of finding the speed end and best by size are the two.
Yes, exactly. So what I am explaining is that if it is best first size, if I am taking best first size for measuring this circle diameter, so this much derivation will not be there, since OB is directly found.
హారం తీసుకున్నామండి హారం తీసుకున్నావా
Is it because like already we know the best by size value?
Correct.
D. Okay.
Yes, yes.
అది మామూలు
So which means in this scenario we don't need this speed. That's what you're trying to say.
Yes, yes. Suppose if this is the best by size, I don't need to do this all derivation. You can directly take the value of this DW and I can find. Since I am not sure this is the best by size, so I am taking the other triangle which I know, which are the parameters that I can measure. So that's why I'm not taking this triangle. Instead, I'm taking the other way to find this pitch circle diameter.
Yes, correct.
Yeah, that's it for today. If you have any doubts, we can stay. Otherwise, you can leave.
Recording.
I have shared the drive. Just a second, I will share again.